Yeah, thank you very much, Charlie, for taking the time to giving us this presentation about prefixes and curies and bioregistry. Everyone knows you here, so I'm not going to spend time to introduce you very much. So just take it away, and yeah, we're looking forward to hearing what you have to say. And thank you very much for taking the time.
All right, great. So let's see how I'm going to do this. I guess I've got some slides. I will share the slides after we're done with this. I want to go back and actually backfill some of the things because I'm going to give a couple live demos. First, let me give a look at who's joining us today. Okay, good. So yeah, many of us have met before, so it's nice to see you all again virtually. Please feel free to chime in, ask questions as we go. Yeah, and then I'm going to teach you a little bit about the bioregistry and curies. But I want to actually tell a little bit of a story first. I was thinking about, where does this whole line of work begin? And I guess it's back in 2016 or 17 when I was a master's student and I was working with this format called the biological expression language, which was like sort of this proto knowledge graph sort of thing. Let's say LinkML and BioLink are maybe the logical successors to Bell in terms of encoding like mechanistic biology. And in this, I was starting to learn about all these namespaces. And I started to learn about Go and Mesh and EFO, and they were these kind of spacey things to me back then. I think a lot's changed since, but it was the beginning of my journey into learning what all these things were. And the problem is they had all these prefixes, and I didn't really know what was going on. So somehow this presentation is mirroring my journey from not understanding what all the prefixes were into knowing what to do with them. And somehow it's like a nice retrospective. So I'm going to talk a little bit about bioregistry and about the curies package. And yeah, so I don't know. I haven't attended many of the obo-academy series. So I hope that I hit this with the right amount of like technical stuff and high level stuff. If that's not the case, anyone can feel free to chime in and I can like seriously divert the talk to something else. So the three main takeaways from today is please standardize your curies and your prefixes everywhere that are showing up. And actually, this is also missing. You should standardize your URIs as well. Within the confines of like the obo world, everything is an obo Perl, but that's like not the reality. There's a lot of content that's living in different places with much more heterogeneous IRIs, curies, and prefixes. So, while you're on the goal to doing that on your crusade, use the curies package to accomplish this on a technical level. And I'll show you exactly what I mean by that. And then use the bioregistry as a harness to do this on like a social and community level. And as you all learn a little bit more about what's the bioregistry about these days, maybe you'll see how we can accomplish this, especially as we have, sort of the vanilla version of the bioregistry. Then we have the different communities that touch it and have slightly different opinions on things and how they can all reconcile these together and actually like operationalize and standardize an explanation and maybe a formula for what do they think is different. So let me check the chat really quick. Okay. Yeah, I'll also keep track of the chat. Okay, so just to get everyone on the same page, there's kind of the two flavors of semantic web identifiers. There's curies, which is on the bottom. I've got this example of a curie for Kibi. Curie stands for compact URI. And then there's like URIs, like this obo Perl for Kebi. And so both curies and URIs have kind of a beginning part, which is the prefix. So in the URI, it's a URI prefix, and in the curie, it's a curie prefix. And then both of them share the idea of a local unique identifier. And so that's the part that actually corresponds within your semantic space, like in this example is Kebi, to the thing that you're talking about. So here we're talking about this molecule called alstrapalone, and it's got this number 138488. And depending on what kind of format you're using to talk about it, or what syntax rather, you can use this part, this URI prefix, or you can use this curie prefix. So prefix maps are a way to kind of go between these two worlds, because depending on what format you're using and depending on what kind of people you're working with, you may be interested in using URIs or curies, or maybe hopefully not some mix of both of them. So the idea of the prefix map is a data structure that's a bijective mapping, which means that there's no duplicate keys and no duplicate values that go between your curie prefixes and your URI prefixes. So I think you've probably all seen something like a prefix map before. You would have the prefix on the left for the curie, and then the URI prefix on the right. And so, yeah, you find these in XML, you find them in RDF. People use prefixes in Sparkle. These show up everywhere. We've got a couple pain points with respect to prefix maps, and this is going to be the way that I want to frame the rest of the discussion. First is we need a standard and a faultless piece of software for working with these prefix maps, for going back and forth between between curies and URIs, or also for parsing URIs. And we need to be able to handle some overlapping URI prefixes. This is especially a problem within the obo foundry world, where most prefix maps also contain the high-level obo prefix, and most implementations are incorrect and don't handle that properly. We need to have multiple programming language support. I love you working in Python, but it turns out that there's a lot of stuff that needs Java support as well. So we need to have the same algorithm implemented in a standard way in many different languages. On top of that, prefix maps have kind of a missing part where they don't really deal with multiple different possible curies, prefixes or URI prefixes or synonyms for these things. Like it or not, there are many different ways to write a curie and many ways to write a URI for the same entity. And we need to be able to deal with this in a reality, in the practical world. Yeah, and we need to have consistent reusable definitions of prefix maps that are sort of external so people can reuse them. And so this is where the Bioregistry comes in. This is also in smaller scopes, this is where the obo Perl system comes in. Mondo has its own sort of prefix map. Go has its own prefix map, and lots of communities build up their own ones. So we want to be able to standardize these when possible. And then as data scientists, we want to be able to use all of this and all the technology and all the social aspects of the first three things to help us standardize our curies and our URIs and our content that already exists. This has to do with inconsistent capitalization of prefixes, the appearance of the so-called banana within local unique identifiers. And we want to make sure that this is standardized, within our content that we create, for example, and the cross references of ontologies. And so this is all these things have maybe come to build some of the tools that I'm going to present. So kind of let's get going. And the first thing is going to be about this faultless software for working with the prefix maps. So I just want to present the curies package. So this is the Python version of it. The Java version does the same thing, basically in the same way, just with a little more Java syntax. And inside the curies package, there's basically this single object called the converter. And you can build up the converter object from a prefix map, just like the one I showed on the other page, or a couple other different formats. For example, JSON LD contexts. It can load those. It can also load this other notion of the extended prefix map, which we'll come back to. And once it's loaded that thing up, it can compress and it can expand. So it can turn a URI into the appropriate curie. It can turn a curie into the appropriate URI. It also has under the hood the functions for parsing a URI and for parsing a curie. Which also depends on sort of the definition of the prefix map. So, there's the point to this is that there's a lot of incorrect implementations of parsing URIs. And so one of the places where this shows up, like I mentioned, is that many prefix maps have overlapping URIs prefixes, like the Mondo prefix, and then also the generic obo foundry prefix. Oh, there's a typo in there. And so most packages implement this themselves, and they kind of iterate over a dictionary backwards, which doesn't have any guarantees that you're going to get the best one. So the solution to this is actually to use a specialized data structure called a tree. And this ensures that the longest URI prefix is always matched. The other benefit of having a tree is it also is a very fast lookup. So you're able to quickly use this over many URI prefixes, for example, in a loop. So we've already the history. Okay, Sierra asked, what's the history of the banana term and why we call these bananas? So I don't have a slide for that, but I will explain that when we kind of get to the Bioregistry part. So given the curies package, we have this sort of correct implementation of parsing our URIs. So the next thing that we want to address is sort of the ability to have synonyms for both our curie prefixes and our URI prefixes. So taking a step back, the heterogeneity for curie prefixes is absolutely massive. So if you look at NCBI taxon, a massively widely used resource for talking about taxa, in many different places, there's different prefixes used for it. So, the identifiers.org system uses taxonomy. The obo-founder uses NCBI taxon with a special set of capitalization. Bioportal uses it fully capitalized. Cellosaurus has this NCBI_tax ID. Go uses just taxon, and so on and so forth. There's many different places using it in many different ways. So, we need to be able to standardize these sort of things. I'm sort of burying the lead here by putting Bioregistry in the middle as sort of the solution to all of this, but we're not quite there yet. On the other side, there's also the URI prefix problem, where there's a massive number of URIs that can be used. And, you astute obo people out there will say, yeah, there's only one real URI, which is the obo Perl, and this is the canonical correct one. That's kind of true, but in reality, you see lots of different URIs for different things showing up in different places. And identifiers.org also sort of proliferated this issue by having like the HTTP versus HTTPS problem, and then also having this colon versus slash problem. So, depending on the data you get and where it comes from, it might have like one or many of these different kinds of URIs referring to the same thing. So we need to like standardize these as well. So how do we deal with this? We need a new data structure that incorporates more information about the more kinds of heterogeneity that exist. So it's not just enough to have our favorite prefix and our favorite URI prefix, but we also need prefix synonyms and URI prefix synonyms. So here I'm introducing a new data structure, which isn't really a web standard, but this is something that the Curies package implements. And I hope it's not very controversial. The idea is, rather than just having a simple dictionary, we're going to have a list of these dictionaries that are data structure that contain a little extra information. So for each prefix and URI prefix, like this one for Kebi, we can include some extra prefix synonyms and some extra URI prefix synonyms, potentially several. It's still important that this data structure denotes what's the preferred Curie prefix and URI prefix. So here, this is like capitalized Kebi, and this is also using like this obo Perl. And you can see that this is like, this is just written in a JSON sort of data structure. So this can be encoded in many different places in different formats. And then this is like an easy thing that corresponds directly to like, let's say a class in an object-oriented programming language. So you can implement a way of loading and dealing with these anywhere you want. However, you don't have to, because the Curies package already does it for you. So what does this look like? Once we can have lots of different parts, not just our simple prefix maps. So this example is using Go. Here's a Python example that shows where we're creating this converter object again, but this time we're creating records, and then that has just an example for Go, but there could potentially be many. That includes prefix synonyms and URI prefix synonyms. So now we can see we've got this functionality exposed to standardize either a prefix. So sometimes you see people use Go MF as a prefix for Go, but like this doesn't really make sense. It's really just a part of Go. And so the identifier should have Go as their prefix. So you can see that our prefix can be standardized to Go. We could take a Curie, we can standardize it from Go MF : and then the numbers to being like Go and then the numbers. Similarly, we can also standardize a URI. So this example is showing like, if you go to the website, you go to amigo.geneontology.org. And so you don't want to use this within your standardized places, but you may get this data somewhere because people were like copy pasting links out of the web browser. All right. So actually the next thing you kind of get for free, and this is if you want to put your data scientist hat on, is that once you have one of these Curies converter objects, we can also work in bulk on, for example, we've implemented utilities for working with pandas data frames. So you can compress or expand a given column from Curies to URIs or URIs to Curies. You can also standardize a column that has prefixes, Curies or URIs. So these aren't like really well fleshed out examples, but we'll come back to that later at the end and show a full example. And I'll link to one where I use it to deal with the gene ontology annotations file and like deal with some of the inconsistencies that are there. Okay. There was one comment. I want to just check. Okay, so yeah, so we've already started using Curies in a couple places. Okay. So Nico asks, can you speak to dealing with conflicts? Let's say we have the same Curie prefix associated with two different records. That's a great question. The answer is we're not ready to solve that problem yet. The Curies package is, let's say, it's self-contained. It doesn't make any choices about what your prefix map is. It doesn't make any choices about what's good and what's bad. It just takes in the data and then it follows an exact algorithm. What it will do is if you have conflicts within your prefix map, let's say you have two different records that have overlapping curie prefixes, it will give an error because this is an inconsistent definition of a prefix map. So the curies package assumes that all of the data has already been well thought through. And so how do we deal with conflicts potentially that show up between different communities that may reuse the same prefix in two different places? Or recently we've had a problem where we're trying to convert a lot of content that uses DC and DC terms. And people actually inconsistently use DC and DC terms to point to the namespaces for DC elements and DC terms. And so you may have two URI prefixes that overlap. So the curies package, it doesn't solve that problem for you. We actually need to kind of think from a bigger perspective. This is more of a social perspective. How do we solve this problem on a technical level? And I'm going to come back to that when we talk about the bioregistry, because the bioregistry does solve that problem. Okay, and then Sierra asks, isn't this what the GitHub prefix maps repo does for us, provides conflict resolution? And I'm not responsible for that one. And it's still sort of, well, yeah, it's related to the way that the curies package works, the bioregistry package works. So maybe someone else, maybe Sierra wants to comment on that as we get to the end. Okay. And any other questions before we move on from this part? Okay, so the next thing is we need a consistent, reusable definition of prefix maps for different communities. And so, you know, I mentioned before the solution to this is the bioregistry, but this problem is sort of permeating lots of different places because everybody wants to try and reuse prefixes. It's nice to reuse prefixes because it allows us to take data that are in different places and combine them together readily, but it does mean that we all have to use the same ones ahead of time. So what I think is a better version of this is to say we have some way of standardizing everything and then applying it to places, to data from different places. So big questions that go along with this. What are all of the prefixes and, you know, their associated metadata? Who keeps track of them? Or rather, what are the registries of all these prefixes? What exists already? What's sort of not in a registry? How consistent are the prefixes used from registry to registry? And like, what are the conflicts associated between them that we might need to resolve, which is what Nico and Sierra just asked about. And how good does each registry cover sort of the kind of content we'd want to use as biologists or bioinformaticians or chemoinformaticians? And can we do better than what exists? And I give, you know, smiley face because I think, yes, we can, and we're getting there. Okay. So one thing to note is there's actually a lot of registries that keep track of the things that I just mentioned about what are the prefixes, and they actually keep track of different kinds of information about them. So some of them are like resolvers. So this would be identifiers.org name to thing, prefix commons. These keep track of the prefix and then the URI prefix associated with it for the purpose of being able to take a given curie and send you to a place on the web that actually gives you some information about that. Similarly, as like these lookup services, which themselves contain information about the curies. So that would be typically like ontology services like OOS, Ontv and ABRL. Then there's like, you know, more ontology specific registries, which potentially provide resolution services. So Obo Foundry Bioportal, AgriPortal, these other OntoPortal Alliance instances kind of lives in that category. And then there's like database specific registries, which keep track of the URIs and the curie prefixes that are associated with things. And so like Uniprot, Gene Ontology, NCBI, Cell Source, and like a couple other projects maintain their own registries. And then there's kind of like the miscellaneous category, which is like Wikidata, Fair Sharing, BioLink Model, which do some similar things to the other ones, but, you know, have different like purposes. So they don't always keep the same kind of metadata, and they're not necessarily set up for us to do data integration, data harmonization. So if you want to know a little bit more about this, there's a comparison on the bioregistry website between all the functionalities of all these different registries. So, okay, there's issues with, you know, what exists already, right? So they've all got kind of different scope and metadata standards and purposes that means that they're applicable in different domains. So like, it's not always useful for helping us to standardize our content. A lot of the main problems with the registries themselves are data are incomplete, they're out of date or inaccurate. And more importantly, it's problematic because maintenance is stalled. So some of them, I would give identifiers.org as an example of a resource that is having a hard time keeping up with staying up to date and with keeping both its technical and curation infrastructure running. Yeah, and most of these projects don't have governance that supports like allowing other people to make contributions or make small fixes if they find issues. And then the last part is because there's so many different things, they're actually not aligning their content for the most part. There's a few examples of this where it actually is happening, like name to thing basically imports content from a couple other registries in bulk. But they're not proactively trying to make the connections between the same content in different places. So before I move on, let me check the chat. Okay. So what's the solution to all these problems? Oh, it's the bioregistry. The bioregistry is a collection of all the prefixes that might appear in your semantic web content and the associated metadata with them. So this includes stuff like the name of the project, so the name of the semantic space, websites associated with it, people who are working on this project. There's a lot of content. I'm going to come back to some examples and we can show you them later. The novel part of the meta registry is that it creates a place where we can store mappings between the prefixes that appear in other registries, and using the bioregistry as a hub for this model. So we can know that the gene ontology notion of NCBI taxonomy, which is just called taxon, is the same thing as the obo-foundry notion of NCBI taxon. Built on top of this, because it has information about the URI prefixes associated with all of the different prefixes, which are curie prefixes. It's able to do this resolution similar to name to thing and identifiers.org. And then the two most important things that sort of promote its longevity and its sustainability is that the bioregistry is using this open code, open data, open infrastructure model, which means that anybody can look at the content. It lives on GitHub. You can make improvements directly by making a pull request to the single source of truth JSON file that like the whole database lives in. It's like a couple megabytes total. So that's not a big problem for anybody to get or to share with each other. On top of that, everything's permissively licensed with CC0 and the code is licensed with MIT license. So people are free to take this content and do what they want with it and make reasonable changes to it. And then, so this is all built with this kind of community-oriented mindset, which means that there should be like contribution guidelines that help people to get up to speed on how to make contributions. If they, feel like they need to make a tiny drive-by curation, they can do that. If they want to make a more substantial curation, like adding a prefix, they can do that as well. And it sort of supports them with doing it. We have a code of conduct and a project governance that allow this project to sort of continue past, the original people who have made it as they move institutions. And this is really important. Most projects are not starting with that. So with all that being said, so let's come back to sort of the technical aspects of the bioregistry, and then we can zoom out a little bit and try and answer some of these original questions that I posed and that you've posted in the chat. So the first is the bioregistry is covering the content from all the external registries. So it is bigger than the sum of all the parts. It contains, for example, on the top of this, like the entirety, all 795 prefixes from identifiers.org, plus 909 extra ones on top of that. It's the same thing for OLS and obo-foundry. Of course, there's a lot of content that isn't in scope for OLS and obo-foundry that also exists here. And then you can look all the way on the bottom where there's actually a lot of content that exists within ABRAL, for example, that's not within the bioregistry, or you can see also, bioportal. So these are the prefixes that aren't in the bioregistry that are in these other places. And then there's various reasons for content not being brought into the bioregistry. So one thing is certain resources are considered high quality and are imported in bulk. So that includes like identifiers.org and obo-foundry and name to thing and a couple others. And then some contain a lot of content, which is like a little bit lower quality. So I would say in Bioportal, there's lots of ontologies with like very short names, which probably will never get reused. And so they're not necessarily the best idea to bring in bulk. So as people say, hey, there's content in Bioportal that we're really interested in, including the bioregistry, they can say so, and then it gets imported. Now, every night, the bioregistry tries to align its prefixes and all of the synonyms it has for the prefixes with the ones available and all these external ones to like proactively make mappings. And so those are done with some automatic rules, and then the ones that can't be automatically mapped are suggested for manual curation so that we can go through fix that. In fact, these mappings themselves are actually, they're curated and distributed in the SESAM format. So, you know, it's very meta. So also SESAM uses Bioregistry, but Bioregistry uses SESAM. Okay, and Nico says, just note how much work it must have been to curate prefix synonyms at the scale we do here. It was a lot of work. I think there's probably, well, we'll get to the number. I think there's on the scale of thousands of prefix mappings. Yeah. So many of them have been semi-automatically curated, and a good number of them have been manually curated. So sometimes it's really difficult to figure out what's going on. And in fact, you can go on these very long and difficult discussions trying to figure out what's going on. Right now, there's a discussion ongoing about the difference between Orphanet and Orphanet.ordo and how these are mapped between different places. And so, like, you know, the community can try and figure this out, or you can bring in people who are actually in charge of these resources to help solve these problems. But then you have to unpack what are the assumptions that every single other registry made and deal with those. So yeah, actually, it's a good place to come back to the question about collisions. So different registries may have different topics and focus. So for example, identifiers.org, it registers the GEO prefix to the gene expression omnibus. So this is a database that includes, you know, gene expression experiments. Now, within the Obo Foundry, the GEO namespace is pointing towards the geographical entity ontology. And so when you want to align the identifiers.org and Obo Foundry resources through the Bioregistry, you know, it's a problem because GEO means two different things in two different places. And so the Bioregistry maintains this list of namespace collisions, or prefix collisions rather. Yeah, so, you know, people are typically using the word namespace when they're talking about prefixes if they're from the semantic web world, because this is how a lot of semantic web vocabulary defines it. So what happened in the case of gene expression omnibus and geographical entity ontology is the Bioregistry preferred to use the identifiers.org definition. So GEO within the Bioregistry points to gene expression omnibus. And then we had to pick a new prefix to mint for geographical entity ontology, which I think we picked with sort of the consent and advice of the maintainer of GEO, the ontology, to be GEO. So geographical has a GEOG in the beginning, and then it was entity ontology, so then another EO. And so what happens is the Bioregistry explicitly keeps track of sort of a negative mapping, which, by the way, SESAM also supports storing and these negative mappings. So it has a negative mapping between the identifiers.org GEO and the Obo Foundry GEO. And it has a positive mapping between the Obo Foundry GEO and then the Bioregistry's GEO. So it's a little bit confusing, but given all of these sort of collisions and all of these things that exist, we find them as time goes on. And I think there's probably like 50 curated namespace collisions between like well-known resources. So there's probably actually a lot more, but we haven't run into them because we kind of keep this long tail of low quality content out. So we're able to deal with that and then use technical solutions depending on what flavor of content you want to get. To maybe recapitulate the prefixes in the way you want. And I'll come back to that with this concept of contexts in a couple minutes. So one question for the chat and for Nico and Sarah, how much more time do I have to talk and how much time do we want for discussion?
This is completely up to you, Charlie. Generally, we usually do like about 40 to 45 minutes talking and then 15 minutes questions, but
perfect.
It's up to you.
Yeah, I was planning on going for about 50 more minutes, so that's great. So let's kind of move on, and when I'm going to give sort of a live demo of the Bioregistry's website, and I'll show exactly where this solution to the prefix conflicts kind of comes into reality. So yeah, in case you weren't already convinced that the Bioregistry is sort of the substantial leap forwards on what exists already, here's sort of a chart that shows, you know, how many external registries have a given prefix. So most you know, prefixes are only available in one other one. Some of them are available in 2 or 3 or 4. NCBI taxon is the, you know, golden egg that's available in 19 of the different external registries. And then, you know, 247 prefixes are completely novel in Bioregistry that nobody else has curated. I invite anyone who wants to just take the content out of the bioregistry because it's got this CC0 license. So in theory, this 247 novel could actually be 0. But that's kind of how things go. Yeah, and I already mentioned the bioregistry's got this kind of open source, open code, open data, open infrastructure approach that, has allowed, like, you can see down here, this is a screenshot of the GitHub repository. 58 people have made contributions, maybe only 56. It looks like GitHub is counting itself twice. But, like, people have said, hey, I want to add like a very small change to it. And this has happened many times. And so I think this is a good way to make a project have longevity and go into the future. All right, so yeah, I already mentioned this other idea that bioregistry is kind of curating content manually, but it's also got this semi-automated alignment approach. It's not actually just making mappings to other registries just for the fun of it, but the bioregistry is trying to deduplicate the need for curation. So let's say that there's a record in identifiers.org for some database. Let's say it's like gene ontology. There's no reason for us to curate that content ever again. They did a great job in it. In identifiers.org. So all we have to do is import the content from these other places. And it turns out that most of the other registries have pretty nice licensing, with the exception of fair sharing and EDM ontology, which use like these Creative Commons share-alike license, which aren't so great for redistribution. But anyway, for the most part, we're able to bring in content and then, so the alignment happens, and then also import of content happens. And then also every night, after that happens, we make a deployment, a new release of the bioregistry to PyPI, to Docker Hub, and then to like this website on AWS. So the latest content can always be used, and you can potentially pin the bioregistry version to a certain day if you want to be like really sure things never change. In addition to like making these deployments of the code and like the website, it also builds lots of different artifacts, which includes like a prefix map and an extended prefix map, which you can directly import into the curies package before. And this is actually what we're seeing is people would rather rely on the curies package, sort of like a standard implementation of some of these algorithms I mentioned before for compression and expansion and standardization. And then they don't need to rely on the bioregistry as a Python package or as a set of code, but they can only just take the data that they want. So in addition to that, it also makes charts and summaries like these, figures that I was showing you. They get generated every night. So I just like copy pasted the most recent ones into the slides today. And then it also makes an external archive to Zenodo and GitHub releases. So, the data, it exists in many different forms in many places. So like the legacy of the bioregistry, ideally, if for whatever reason the project has to end, the content can be brought to the next place. I would like to see that the project just evolves to the needs of the community as that's necessary rather than starting a new project. But, you never know how this is going to happen. All right, so also in terms of project longevity, a lot of people asked on the first bioregistry sort of like community meeting that we had, what's going to happen? How's this project going to look in 10 years? Will it still exist? So all this automation stuff was really important. So in terms of the longevity of the project, it runs on the smallest possible Amazon Web Services instance, which is called a T4G Nano, and it costs $20 a year because it has like 500 megabytes of RAM, and the Docker image for the bioregistry is like 80 megabytes, and it runs with like 50 megabytes of RAM. So that's really cheap. The website, the domain costs $30 a year. So in theory, like, this thing could be running for a long time, even out of like pocket change. And like I mentioned before, yeah.
Charlie, can I just, because we recently debated this question of how to actually trust a longevity statement like that. So we, when we reviewed the kind of like the risk of using w3id.org, we also, from the kind of governance discussion on their end, they say exactly what you're saying here. Basically, it's a tiny amount per year that they invest, but in the end, there's still a little bit of a risk in that you are the sole, let's say, owner of the namespace, and it might be the case that, for example, I will accidentally piss you off so much that you say, I'm not going to work with Nico again, and I'm shutting bioregistry down, and no one will ever see the bioregistry domain ever again. So you see, like, I'm making an extreme point here. Do you have a feeling of whether there is a way generally to make that a bit more safe, like something like where we can have a more trustworthy guarantee that a project will at least exist for like the next 10 years or 15 years or something without any personal kind of like conflicts affecting this trust?
Well, okay, first for the W3 ID thing, I don't want people to start using Bioregistry URLs as pearls. Like, you shouldn't trust it to do that. It's not the job of it. You should like ask people what they want the pearls to be. But in general, is there a way completely around it? I mean, someone's credit card has to be onto AWS at the end, right? So there's always going to be like a single point of failure that I don't know if you can have multiple credit cards, or you can have some kind of external organization that exists and its job is to make the payments. We asked people for funding. We said, hey, it costs $100 a year to run the bioregistry. Will you give us $2,000 so we can pay for 10 years of hosting the bioregistry up front? And everyone we asked for that, they said, nah, we don't really like to do funding like that. They don't like to do long funding. So I don't know, maybe I could just pay $2,000 out of my own pocket and say, hey, look, this is something that's worth existing. And so I paid for it. But like, there's also a problem with doing that. The best thing I can do right now in sort of the young phase of the bioregistry, a project that's existed for a couple of years, and I've been sort of pushing it as sort of a community project in the last few years. So there's the reality that I've done most of the work for this project. We put together a team that includes Tiago Lubiana, Megan Balk, and Tiffany Callahan to be people who also have admin rights on the GitHub organization. And so, in theory, they can make all of the decisions that I make, and they have the administrative rights to doing that. And so within the onboarding and the offboarding, there's also like this very uncomfortable set of rules for like, what are the rules for removing somebody from the GitHub organization and taking away their rights and that sort of thing. So like, if I were to be like super petty, like, I don't think this is going to happen, but if someone who is the project like administrator were to be super petty and make a decision like this, I feel like the community's code of conduct would be sufficient to say we can remove this person from the project, or we can limit their access and their ability to do these sort of things. So I don't know. There's no foolproof solution for this. You can't really trust anything that exists for a long time. I don't know if you saw recently, but Microsoft is like cracking down on VS Code being a nice and open source like software. So yeah, Nico mentioned in the chat, having a biomedical data nonprofit which can take care of the maintenance of such a resource would be great. The Global Biodata Coalition is one of those kinds of concepts that they may be able to do this. I'd love to be part of that. And I think that Bioregistry is a great example of a really low hanging fruit for showing off that this is possible, because it's very cheap to run this thing. So it wouldn't be like a very expensive test for such a governance structure. But yeah, you're right. We need to keep having these discussions. And I don't know if people have more ideas on how to improve the governance of the Bioregistry. Obviously, in my opinion, the best way to solve this is to get more people to be significantly active contributors. So I mentioned that there's the 3 others who have the administrative rights, and we chat about things, but it's still like there's some kind of imbalance in how much people are active. So if there are more people active, then we definitely see like better longevity and sustainability in this perspective. So I invite anybody who wants to get more active or start becoming active in this project. I will mentor you and walk you through this and more carefully go through all the parts. So yeah, that offer is always open. Let me try and let's see. We've only got a couple more things left in this, right? I have a couple mentions of live demos. So I've got a slide for the live demo of the website of the Bioregistry. Specifically, I want to talk about this community-driven contexts, which I helped, which Nico and I developed together as sort of a way to reconcile how different communities may have disagreements, because there's no possible way to have a bunch of different communities agree on the same standard. For like 99% of the case, it actually works, but there's always going to be stuff that has to be my way for everybody. So that's kind of the solution for that. So I'll come back to this. I could give a live demo of the Python package for the Bioregistry, and this depends on if the group here is interested in that. So if you want to see some Python live demoing, we've got like 19 minutes left before the top of the hour, so we can do that, or I can just give you guys some resources to see that for yourself in case you want to access this code through Python instead of like through a web API or just by downloading the content itself. Okay, this is live demo of something, I think. Yeah, okay, so then there's also this standardizing data that I mentioned before. And I said it's sort of a first try using the curies package because the Bioregistry package itself wraps the curies package in many ways, and it extends its functionality in ways that really aren't standard. So like I mentioned before, the curies package sort of implements the really strict rules about what it means to expand and compress curies and URIs between each other, and to have a very strict definition of what your prefix map is. But the bioregistry kind of goes beyond that, and it deals with some more, let's say, like biomedical use case driven standardization, like custom rules, which involves dealing with this banana thing. So I come back really quickly in a couple of minutes to talk about the banana thing. It also deals with kind of this other problem where URI prefixes actually aren't enough most of the time. So, we talked about this like obo-Perl, where you kind of got all the beginning part and then the ending part is the local unique identifier. But it turns out that actually there's lots of resources that don't have like proper semantic. I think this is what Chris Mungall calls semantic URIs, where it really like has the right sort of URI prefix and then the local unique identifier comes at the end. So here's an example of this rebase database. So this is like a database of enzymes. And so if you want to look local unique identifier like 101 for some enzyme, if you want to make a URI out of it, you actually have to stick it in the middle of the URI. And so that's not so great for this concept of expanding and compressing URIs. So, we need to actually kind of go a little bit more sophisticated than just a URI prefix, and then come up with this concept of the URI format string, where you have this $1 as the placeholder for where the local unique identifier goes. And that allows you to sort of represent this URI as something that we can resolve. So if you've got the local unique identifier, you can actually generate and then resolve to a URI that shows you something on a web page. So this is like another consideration the bioregistry sort of wraps up. It's also possible to have a more generic notion of parsing URIs that deals with these URI format strings instead of just URI prefixes. So this goes beyond like this tree data structure, gets much more complicated. Okay, yes, and then the next part after that was, somewhere in these, these are like all the crazy things that I could add. So okay, let's go back to the bioregistry demo, and I'll do that really quickly. And then I want to also show you this this ontology quality assessment tool, which gives people ideas about like the unknown prefixes that exist throughout sort of the obo foundry. And then you can give me some notes in the chat as I'm going through here. So here's the bioregistry website. The idea is it's giving you some links to all the different parts of it. We can go to the registry page itself, which at this point needs a little bit of some new programming help because the list of prefixes is getting quite long. So we can go through here, and maybe you can search for like chemistry or chemicals, or we can search for Kibi. We can go ahead and look at a page for prefix. So we have the title, we have a description. Sometimes we've got logos for the projects. There's sort of a dichotomy between these bioregistry, canonicalized, standardized prefixes, and then the preferred prefixes. So these are like the stylized ones that people typically want to use within the obo foundry community and otherwise. It has all the synonyms for its alternative prefix, some keywords. It's got other information that it pulls in from different places. For example, the ontology lookup service, it parses the ontology sort of on a chronological basis. And so that metadata is actually available for pulling in from the OOS. It has contact information. This is actually very important. So like you can transparently get in touch with the people who are responsible for these resources. Don't ask me if this is like allowed by the GDPR. This is officially hosted in America, so I don't know what the rules are. It also has this information about local unique identifier patterns. So this helps us for validating and making sure our content is correct in different places. So this is kind of where this banana thing comes into effect. So a long time ago, the banana problem happened when I think it's the fault of identifiers.org, but I'm not really sure. So the problem is that people aren't really sure what the difference is between a local unique identifier, which is like the part that comes inside database, and the curie. So when people accidentally started putting curies into fields that were supposed to have local unique identifiers, you might end up seeing the entire curie written out, Kebi 24876 written out in the local unique identifier field. And so that would mean that if you were to write a curie, you would get Kebi colon 24867. Yeah, so that's the origin of this banana thing. And there's actually a lot of instances of this happening within identifiers.org. So this is really the place where this gets proliferated, because inside identifiers.org, let's say if we link to the Kebi page in identifiers.org, we'll see that it's local unique identifier pattern, right? So this is the part that comes after the Kebi colon. it actually has Kebi inside it for some reason. So this is like giving people the wrong idea. And so if you really want to be like identifiers.org compliant, you start making data that doesn't make sense. So the reason it's called the banana is because the NA keeps repeating over and over again in banana. It's probably not making you very happy now that you know what this actually comes from. And I think the first person I heard banana from was either William Hayes inside the Bell Consortium group, or it was Chris Mungall was the one that I first heard this from. I didn't come up with this. Yep, Harry's got it. Like, actually, it would be more like banana colon, nah. You know, like too many colons inside your query. Okay. So yeah, inside the registry page. So let's go down to kind of the more interesting stuff. So the bioregistry also keeps track of like some of this extra ontology stuff. Like certain prefixes are sort of contained within other ones. There's like this interesting concept of appearing in different places. I'm not going to go into that right now. We're kind of running out of time for that. Here's sort of the meta registry. This is the mappings between the bioregistry's entry for Kebi and all of these external registries entries for Kebi. And so you can see sort of the different sort of prefixes that are used. So many of them use this like fully uppercase Kebi. You know, there's actually even ontologies that are keeping track of the identifiers for things. So like the chemical information ontology also has like a term for Kebi, but it's, you know, this like numeric term, similar for EDAM. Wikidata has a property that corresponds to Kebi, and so this follows like Wikidata's property style. And then there's, you know, like fair sharing has its own like style for identifiers. It says obo-foundry is wrong. I don't want to talk about that right now. Obo-foundry is potentially wrong, or maybe not. So if you want to go to the page that describes the obo-foundry Kebi page, it is lowercase. So yeah, that's a problem for a different day to discuss. You know, after a lot of yelling and screaming, we've actually got an extra piece of information that shows how should the content appear when it's in RDF. And that is an extra annotation that appears in some places, because this is like a confounding different kind of content from what you might use to resolve it to a web page. So like that can be annotated. And then it's also possible that you have some like extra providers that are outside. Oh, okay. Yeah, so you've got some extra kinds of URLs that you can use to find content on this. So for example, we can look to the bioportal resolver, find some things. We can look to the ontology lookup service, find some things, and then we can look onto like Kebi's website. And so there's like 3 different web pages that are all describing the same thing. Yeah, Nico, we did so much yelling and screaming back and forth. I had to do this eventually. So this RDF thing is really important for a lot of people. And so yeah, this shows that we could implement things that people find interesting and useful. All right. So that all being said, let's go to all right. One other thing, and then I'll get to the other part, is that the meta registry is also part of the bioregistry, and this contains information about all the external registries. And if you want to know more about that, I mentioned it earlier, there's sort of this related work page that makes a comparison of like the data models and the capabilities and sort of the governance of all the different ones. So if you want like a really in-depth review of like what each of these things does and how they do it, you can take a look at this. And now I want to come back to this context thing. So the idea of the context is it says the bioregistry, it has sort of its own opinions about everything. And for the most part, they match up to what everyone thinks. But, you know, every community is entitled to its own opinions as well, because in the end, the prefix map only has to be locally consistent. So as long as you define a prefix map and you stay consistent with it, your data is fine. But we don't want to have to keep redefining those things. So it makes sense to take as much as you can from the bioregistry and then just like specify what's your rule set for making updates to it. So again, I mentioned that Nico and I sort of developed this together. And so we came up with a data model for describing what are the differences between the base bioregistry prefix map, or extended prefix map rather, and one that's community specific. So right now we've created one for the obo-foundry, but we've talked about this before. It would actually be really great if we did the same thing for the Mondo group, for the whole Monarch initiative, to have a similar one to this. So let's see, what they've written is the obo context exists for the following reason: to reconcile database cross-references used by obo ontologies and centralize their validation, standardize and validate SESIM mappings, and to provide an incentive for the documentation of non-standard prefixes for obo ontologies. Okay, so let's actually look into this and see what it looks like. The first thing is there's a lot of governance that surrounds this, right? So while most of the bioregistry content, the people who are the administrators kind of have carte blanche. They can make updates to it. It's part of the governance that only the people listed as maintainers are allowed to touch these context files. And so Nico and Anita are the two maintainers for this. And so what they've done is sort of defined what are the rules for modifying the bioregistry's extended prefix map. So the first thing they do is they're reordering the prefix priority. So the bioregistry pulls in content in a priority order from different places. And so they want to put the obo-foundry content as the most preferred. And then if there's content available in obo-foundry, it should override the content that's in the bioregistry, like that's been manually curated in the bioregistry. And then, so this is for prefixes. And then if there's a preferred prefix specified in the bioregistry, that becomes the next highest priority. And then the regular prefix from the obo-foundry. So this is actually redundant because all obo-foundry entries are required to have a preferred prefix. And then finally, whatever the bioregistry's default prefix would be used. So for example, this solves the GEO problem because the gene expression omnibus is the GEO one. So that would get, normally that would become the one that gets pushed through. But here, the gene expression, the geographical entity ontology gets to have the GEO one because of this change in the prefix priority order. Similar idea for the URI prefix priority. And then the last part is to have like a standardized prefix remapping. So ensemble becomes capitalized ensemble. The bioregistry's notion of ICD-10 actually gets mapped to ICD-10 WHO. The bioregistry uses PubMed as a standard one, but the obo-foundry typically wants to use PMID. This one's a little controversial, but yeah, fine. This one I really disagree with, but it's not my place. The SNOMED CT gets turned into SCT ID. I really don't like when the ID gets added to the end. I think that doesn't make any sense. Yeah, and then the last one is the custom prefix map that gets added. So they remap PMID to have this URI prefix instead of the default one. The last part is the prefix blacklist. So like this ICD-9 prefix gets completely thrown away. So these are sort of parts. I think not all of the potential remappings that we could do or rules that we could apply to make like extended prefix maps that are useful for the obo-foundry community. And then this gets generated as extended prefix map file. It gets made into a JSON LD context file. It gets a shackle file, and all these things get exported. And so every night this gets put with all the other artifacts that get generated from bioregistry. So the obo context benefits from other regular updates to the bioregistry as well. All right, there's 5 more minutes, so I'm going to backtrack and I'm going to go to the live demo of the OQUAT, the ontology. Oh, okay, what is this called? The ontology quality assessment toolkit, something like that. So the idea here is that the bioregistry contains all this information useful for validating cross-references and curies and all this kind of stuff that shows up in different places. And so it runs through on a loop, I guess once a week, and it opens up all of the ontologies that it has information about how to download. And then it goes through and it parses those ontologies, and then it checks to see to what extent the prefixes are standardized across different curies. And then it makes a report. So for example, we can look for unknown prefixes. So it turns out that URL is not registered in the bioregistry. It doesn't really make sense to be a prefix, so this is going to stay like this. I don't want to have a discussion about if it's a prefix or not. So if there's a URL reference, then appearing in a place where it's supposed to be a curie, then like this gets shown up here. Maybe a better example is GAID. So this is like something that shows up in Uberon a lot. I don't know what GAID is. I've asked a couple places and nobody's answered. Yeah, Nico just asked if there's any questions. So I know we're like 5 minutes from the top. So if anyone has questions or we want to do discussion, we can do that. Otherwise, I can quickly finish up on this website.
I would suggest, Charlie, just to give a 60-second pause to see whether there are some questions, and we can use the last minutes then after that, because for me, it's really important that at least the kind of like pressing questions of the group are at least voiced. Hopefully they were voiced in the chat before, but is there anyone who wants to ask something or related, unrelated? Is everything clear? Everything was already answered? I mean, we've answered quite a lot of questions in the chat already. Some hearts, good. All right, yeah, Charlie, if you want, you can then just continue with your conflicts explanation, because I think it's quite interesting to see all the work that we should be doing as a community to reconcile the conflicts that Charlie has identified.
Yeah, so let's say like there's a way to take a perspective on a certain resource. So Uberon's been very proactive about this. So I like using them as an example because there's still a lot of work to be done in Uberon. So, you can find like these really bizarre cross-references showing up. So like there's a query that's written AOO:LAP. So, this could be like somebody's initials, part of some project they abbreviated AOO, who knows? Weird stuff shows up like brainspan:brainspan. This is like nonsense. It can probably just be deleted. Here's one that's probably like, this is probably Anne's initials from the BG database, right? And so maybe she used this as provenance. The Obo Foundry community wants to move towards using ORCIDs as provenance from now on. So hopefully we can fix all that kind of stuff. Let's find some more interesting examples that are like real examples. So here's like references to some resource called LG. This actually could be interesting to figure out what they mean by LG, though it's not very impactful because there's only a couple references to it. Let's find one where it's probably more impactful. Yeah, I would say this thing with the GAIDs. Yeah, so there's 771 instances of GAID showing up in Uberon, and so it looks like my table's kind of been borked a little bit right now, but this is showing up a lot. So asking around Uberon and saying, hey guys, what is this, and can we register it in the bioregistry so everybody can get this context when they see the Uberon resource. They can ask the bioregistry, what is GAID? So this is like a community resource in many different ways at this point. It's a tool for us to understand what are the references being made. It helps us standardize the references. It powers these other pieces of software that we're building on top of. So yeah, I hope we made it to the end of all those questions on my list, right? So I think the points were standardize all your stuff, do your best, whether it's your project internal standard or ideally to like this external community standard. Do that, technically using the curies package. So I even, unrustied my Java skills and managed to get a package up onto Maven. So I'd love to see that like showing up in other places. In fact, the ontology lookup service now uses the bioregistry to resolve queries and to make links on cross references. So like if you really want people to have an impact of your content, people use ontology lookup service to look at content for the most part. And so if you really want it to be valuable, then you like give it as much context as possible with the bioregistry. And then, yeah, the bioregistry is the place where we can have these discussions about, are these the prefixes that really the community wants to be the ones that everyone uses? And we can solve these like conflicts, like different perspectives with these context, with the concept of contexts. We can, add new stuff. If you've got input, there's like, I didn't talk about the curation workflow so much for bioregistry, but most of it's just like you open a GitHub issue, and then there's like a pull request automatically gets made with whatever the fix you wanted to make was, because it's got some actions running in the background.
Thank you very, very much, Charlie. On behalf of, I hope, of everyone here, this was a fantastic presentation, and I think a lot of food for thought. And hopefully, we are all now, at least in our hearts, converging on this like very, very contentious issue of where should prefixes be reconciled. And I really hope that especially this contexts are an option for some of us ETL developers. So I just want to say really, really thank you very much, and see you next time again.
Yeah, so let me hype up. I'm coming back, right? You haven't seen the last of me. Coming up with standardized syntax and semantics for talking about what things are is one thing, but actually identifying them, ooh, that's next week's problem, or 2 weeks from now. We're going to talk about biomapping, so we're going to talk about reconciling semantic equivalences, which I think piggybacks on some of the other things that you mentioned about SESM before. So we're going to talk about that next time. Anybody who wants to get in touch, I didn't put any of my information on the slides, but I will get all the information into the Mondo group, and I'll make sure that the slides end up on the page that lists all of these talks. And you can feel free to get in touch with me in email or on the Obo Slack or wherever.
Thank you very much, Charlie. That's perfect. So see you guys
everyone.
in 2 weeks, and bye.